You need to find out the potential energy of this chain. This chain is kept on a hemispherical dome. So and the bottom of the hemisphere has given a potential 0. So you know that U is equal to mgh. So for dm portion, it will be dm into gh. So if this is r, this is theta, then this should be r cos theta. Dm is equal to lambda dl, and this small portion you can write d theta. So lambda dl can be written as r d theta. From here, lambda g r square cos theta d theta, and integration limit of theta will be 0 to pi by 2. 0 to pi by 2. Lambda is m by l. So l is pi r by 2, that is given to you. This is g r square cos theta d theta sin theta, and if you put the limit 0 to pi by 2, sin pi by 2 is 1, sin theta is 0. So 2m by pi r into g r square. So r get cancelled out. So that became 2m gr by pi. In this question, there is a ball of mass m and velocity v is hitting a hoop. The mass of the hoop is also m, and in this manner, you need to find out the omega of the hoop. So this question can be to approach. First, if you sit at this position, then you can analyze. But in that case, there will be linear as well as translation motion. So better you sit at the center of mass, because this mass is attached after hitting. This mass is get attached after hitting. So if this is r by 2, this must be r by 4. This one, because they are of equal mass. This is m, this is m. So their center of mass will be in between at this position. So if this is r by 2, so the center of mass will be r by 4. Now you apply this is not hinge at any point. As this is not hinge at any point, so you will be applying angular momentum conservation about center of mass. So this one is hitting at this point. So about center of mass, the height is r by 4. So mv into r by 4 should be equal to I omega. I is how much? I of this mass, and this mass you need to find out. This mass, this distance is how much? If this total is r, then this is half of r, that is r by 2. So mr square, mr by 2 square. And of this ring, not this, of this ring, about center of mass, this is mr square, and about this point will be mr by 2 whole square into omega. So from there on, you can easily find out omega. Omega is coming v by 6, sir. Just after calculation. So this is the process. So better you sit at the center of mass and analyze the motion rather than sitting in the center of the ring. There is a question given. There is a question given. In this question, you need to find out the moment of inertia about an axis which is perpendicular to the axis. About this one. About this axis. So this is going into the plane. So let's take moment of inertia about this one, about center of mass. So I is equal to dm into r square. Why I am doing so? Because in the question given as the density is non-uniform, rho is equal to rho naught r. So dm you can write rho into sigma into dA better. dA is 2 pi r dr. In place of sigma, you may write rho naught into r. So rho naught into r 2 pi r dr into r square. So from there you can write rho naught 2 pi r to the power 4 dr. R to the power 4 there, integrate 0 to r, then r to the power 5 by 5. This is your moment of inertia I. So from there I equal to beta, I equal to this one. So first you need to replace this rho naught. To replace this rho naught, you know dm is equal to rho into dA. From there rho is rho, dA is 2 pi dr, and just write rho as rho naught r. So from there onward you can write m. So just replace rho naught by rho naught into 2 pi by this by m. So the answer is coming 3 by 5 m r square about center of mass. So about this position, how to do? Just apply parallaxis theorem. So this is, let's assume O. So about O, 3 by 5 m r square plus m into distance square. Distance between them is r. So this is 8 by 5 m r square.